Hi guys, welcome to another AWS tutorial with Olamide, and today we are going to be building a serverless web app on AWS. Now the name of this serverless web app is QuickSum, and QuickSum is a fully serverless web app that calculates exponential and stores every result in a cloud environment. Now, anytime you hear serverless, this means that you are not managing servers, and we are currently building all our architectures on a serverless environment. Basically, we have a calculator that can help you check the base and exponent on the website. So immediately you hit calculate from the front end, it sends the value to the REST API. AWS Lambda, which is the backend logic, runs the Python math, and the result is saved in your DynamoDB. The front end is deployed on Amplify. We also have an API gateway that helps us sense the payload from the front end to the back end where we have our Lambda. Now, Lambda calculates both the base and the exponent and stores the results in our DynamoDB. At the same time, you also get the response back on the website. We created a REST API using API gateway, Lambda for our backend logic, and DynamoDB as our database. This is our tech stack. We are currently using AWS Amplify for our front end. We're using REST API. We created the REST API using our Amazon API gateway. Our Lambda was where the logic, where all the calculation runs. We have our database, which is serverless, DynamoDB. Then the language on the backend was Python 3, where we installed the math library. And our front end was built with HTML, CSS, and vanilla JavaScript. Now, all these stuff has been developed and I already added it to my GitHub. Now, all this has been created and I stored them on a repository on GitHub. To set up this project, you need an AWS account. If you don't have an AWS account, I have done a guide on how to create a free tier AWS account, and I'm going to be attaching the link in this video. You also need a GitHub account and AWS console basics. Now you don't need to worry too much because I'm going to be navigating each console and explaining each concept and button I'll be clicking on. Now let's dive into this. Now before we deploy our front end, let's quickly go and set up our backend architecture, which is Lambda. So I'm going to be opening up Lambda and we're going to be creating a function to carry out these tasks. I'm going to name this application QuickSum. And our runtime is going to be Python. Remember, our backend logic is running on Python. So any programming language you are using for your backend, you need to come and pick it here. So I'm using Python 3.14 for this project. Scroll down and click on create function. So once this pops up for the first time, you can just close this up. Then scroll down to the code page. So we're going to be adding our Python code. Yeah, so it comes up like a Visual Studio Code. For some of you that are familiar with Visual Studio Code, it comes up like this. And you have a basic script here, which says hello from Lambda. But we're going to be replacing this with our own Python scripts. So I'm going to clear this off and copy and paste our Lambda code. So you can find this in the GitHub repo that was provided for you. You can check the description below to find the link to the GitHub repository. Open it up and search out for this Python code. This is our Python script, and I'm going to be explaining what we're using this script to do. Now remember, QuickSum is a mathematical application that helps us calculate exponents. Now, I need to explain what each of these scripts is currently doing. And for some of us that are familiar with Python, you can read through the scripts and easily understand what's going on. But for somebody who's just using this for the very first time, we are going to be explaining this one after the other. Now we have the import.json. Now every text you see on green here, it's a comment just to like explain each lines of code that I have in here. So the import.json helps us to import the JSON module. JSON module is used to convert Python objects into JSON format. Now this other line as well too, we also need to import the math library so that Python can carry out every calculations that we have here. Now at line 7, we had to import Boto3. Now Boto3 allows Python programs to communicate with AWS services. So with this Boto3, right, you can work with your S3 bucket, your EC2 instance, your DynamoDB, your XNS and SQL, and many more services. These two functions help us to return the current time. And we're going to be needing this. And we're going to be needing this when we're storing all our data inside the database. Now coming here, we also need to store our information inside our DynamoDB. So all the information that we get from our calculator will be stored inside our DynamoDB database. So all we just need to do is to replace this particular line with the name of your database. Now, this is another important part of the script. AWS automatically calls this particular function whenever this Lambda is invoked. So AWS automatically calls this function whenever the Lambda is invoked, and it receives two parameters, which is event and the context. Now, this event usually contains the data that is sent to Lambda. And if you look at this, right, our event here was our base and exponent, because these are the two characters, because these are the two payloads that we're sending from the front end to the backend using our math library. After using the event to run the calculations, we need to write the result and the time where that calculation was carried out into our DynamoDB. This last part, which is return response. Now, Lambda must return a response, which is the HTTP status code 200. It means success. Now, once this calculation and all these operations inside our Lambda function is successful, it returns this 200 code, which means it is successful. Before we deploy this script on Lambda, we need to quickly go and set up our database, which is DynamoDB, so that we can carry out this test and see that the backend logic is functioning perfectly. So go to your search, right, and search out for DynamoDB. So right click and open this on a new tab, because we're still going to come back here. So that's why I want to keep this on a new tab. DynamoDB is a serverless database, which means it is fully managed by AWS. So what do we need to do? We need to create a table here where we're going to store all our information from the calculator. So I'm going to name this quick sum DB. And we need to add our partition key. So our partition key will help us write into this table. This is the name of the table, and you need a partition key to write inside this table. So most times I use ID as my partition key on my DynamoDB. So you can start to change this, right? So if you want to change this, ensure that on the Lambda function as well too, you get to the put item and change the ID. So this is it. So if you're using another but maybe like using maybe A, B, or CD or anything, ensure you also change it directly from here. So let's go back. I'm currently using ID, and I'm going to scroll down and click on Create Table. Now we've successfully created our DynamoDB. So let's quickly copy the name and put this name in our Python script. So copy, go back to that place where we named DB name. So I'm going to change this to our database name, right? So I'm going to change this from DB name to the name of my database. So Control V. Oh, I need to remove this, clear this off. So quicksum DB, that's the name of our database. So we need to deploy this. So anytime you put in a script, before you run this code, ensure you deploy it directly to Lambda. So click on deploy and look at this side. You're going to see deploying code. So once it's successful, we can test this Lambda function to see if it's successful. So let's quickly test this Lambda function if it's working. So scroll up to test. So click on test. So give it a new event name. So I'm going to be naming this as test, right? Very important, the event JSON, because remember from our script, we have two events there, which is our base, and we also have our exponent. So remember from our event, from our event, we have two events, which is the base and the exponent. So I'm going to replace in this first event with base, the second event with exponent, and we don't have a third event, so I'm going to be clearing this off with a comma. And so our base 5, so we can say base 5 exponent, let's say exponent 6. Let's say the result. Let's say if the Python script will run this calculation. So scroll up, ensure you save your test, then run the test by clicking on test. So it should give us a return, but let's see, there's an error here. So just in case you encounter this error, right, because I need to go through these steps one after the other, run into the errors and tell you why you might run into this error. Now let's read this error message together. I said error occurred, access denied exception when calling the put item operation. So what is happening here is that Lambda has carried out a calculation and is trying to store the information inside our database. But now it's saying that Lambda does not have the permission to put an item into the database. And that's how AWS has designed the environment. Before one service can communicate or write or do anything inside another service, it needs permission. Just like if you want to pick your friend's item, you need to ask permission. Even if you guys are colleagues or you are roommates, before you pick the item, you need to tell them, oh, please, can I do this or can I use your phone to do this? That is how AWS also respects their services. So before service A can communicate with service B, service A needs to ask for permission from service B. So let's go to configuration. So we need to go and set the role, which is the put item role. So when you get here, click on permissions. Now when you get to permissions, click on this quick sum role. This is the role. So we need to go and add the permission to the role so that Lambda can successfully write into our DynamoDB. Now when this loads up, just scroll down, you can see that it only has just one basic execution rule. So I need to add permission to this guy. So click on add permission, attach policy. We have a lot of policies actually, but I'm just going to search for DynamoDB because we try need just DynamoDB. So DynamoDB, I'm going to give it full access. So scroll down and click on add permission. Now, once we've added this permission, that is Lambda can now write into our DynamoDB. So let's run our test again. So go back to tests and scroll down, run your tests all over. Now it has been successful. So you can see status code 200, which shows that it's successful, and your result is this. So let's go and check this result in our DynamoDB. Let's see if Lambda stored this information inside our database. So come back to DynamoDB, click on the name of your database. When you get in here, click on explore table items. Scroll down to the extreme and you should find this under your items returned. This is our result from the calculation. So this shows that our backend logic is functioning perfectly and it's currently okay. So what do we need to do next? We need to deploy the front end so that we can have this connected to the front end, and we also need something that will connect or transfer the payload from the front end to the back end. And remember, from architecture, we need a REST API to take the information from the front end, put it inside the Lambda handler, run the event, stores the results in DynamoDB, and brings it back to the front end on the website. So let's quickly go ahead and set up our API before we deploy the front end. So in your search icon as well, look for this guy, API Gateway. So click on API Gateway, or don't click on it. So we need to leave this open. Right click and open it in a new tab. So when you get in here, click on create an API. Scroll down, we need a REST API. So I'm going to click on build. So we need to build a REST API. So you can give the API a name. So I can name this QuickSum API. QuickSum API. Then scroll down, right? So for your security policy, please select the recommended one, which is the latest security policy 1.3. Scroll down and click on create API. Now, after creating your API, the next step is to add a method, and a method that can help us take our payload from the front end to the back end, run the calculations, and bring the results back to the front end. We have different kind of method, but the method that can carry out that function, that is taking the payload from the website to Lambda, the Lambda also return the result back to the front end. The method is going to be a post method. So we're going to be creating a method first. So select your method type, which can help us carry out that task. That is, take an information from the front end to the back end, then bring the result back to the front end. So that method is called post. So after selecting post, what is your integration type? We're integrating this API to our Lambda. So that's why we have it here as Lambda function. So let it be on Lambda function. Scroll down and select your Lambda function. So this is our QuickSum Lambda function. So we're going to be integrating this on it. Now ensure that when you are carrying out all these tasks, you are currently in the same region so that you can find all your resources with ease. So scroll down to the extreme and click on create method. Now, after creating your method, the next step is to enable calls. Now, we need to enable calls because calls will help us or help the browser call the API. So for your browser to call the API from the front end, we need to enable calls. So click on the root here, click on the roots, then click on enable calls. So this will allow the front end to call the API from the browser. So we're going to click on post because we're using the post method. So click on post, scroll down and click on save. Now, after enabling your course, the last thing you need to do is to deploy your API, right? So this action is not available while the API is currently updated. So please wait for this guy to finish updating. So after he's done enabling course, this guy will turn on orange, then we can now deploy our API. So after waiting for a few minutes, if it doesn't still come up, you can just refresh the website to see if you have the latest updates. Yeah, so now it's active. So the next thing we need to do is click on deploy API. Now when we want to deploy API, you'll be asked to create a stage. So click on stage, click on new stage, then you can give it any name, right? But I'm just going to name this dev, then deploy API. So once you deploy your API, you'll be given this invoke URL. Now this invoke URL will help us fetch our payload from the front end and take it to Lambda. So this is what we use to connect to our API. So I'm going to copy this and save it on my notepad. So you can open a notepad from your end and save this. So make sure you copy it and paste it somewhere so that you can always like go through it anytime you need it. So after copying this, scroll up, come back to your resources. So let's test our API before finally connecting our API to the front end. We're almost done with this. So come to post, which is our method. Ensure you get to test here. Click on test. When you click on test, just scroll down to where you have this request body. So you can go back to your Lambda and go and copy your events JSON inside your test. So go to test, go and copy the JSON, copy this, then come back to the test you have on your API gateway, paste it. So make sure just change the number so that you can just change the number to confirm that this is working. So you can change this to 4. So base 4 exponent 2, and I'm going to click on exponent 2, and I'm going to click on test. Now status 200 response body is, so this is actually working. So let's check our DynamoDB if they stored the information. Yeah, it currently stored the information. So this is working perfectly. So the final step is to now connect the API to the front end. So anytime we run the calculation from the front end, API will send the payload into Lambda, run the function, Lambda saves the information on our database and returns it back to our website. So the last step is to deploy the front end, which is on Amplify. So go to Amplify, search Amplify, right click and open it on a new tab. Now, once you get into the environment, click on deploy an app. So I've added the source code of this front end to the GitHub. So all you need to do is connect your Amplify to the GitHub. Now, to connect the GitHub to your account, all you need to do is to get the link to the GitHub, and I'll be providing this link in the description below. So copy the link and paste it on your own URL, but ensure you've created your GitHub account before you copy and paste this. So after creating your GitHub account, paste the link on your browser and the GitHub repo is going to open up to you. So if you go to this repo, I've added the index.html and also all the guidelines you need, the architecture, the Python code as well is here. So you can copy the Lambda function directly from here and paste it when you're carrying out these tasks. So all you need to do to get this into your own repo is to click on this fork button. So click on fork, scroll down and click on create fork. So this is going to be available inside your repository. So once you connect AWS to your GitHub, you can connect this guy to Amplify and deploy this index.html where we have our front end. So after you've clicked on the fork button and it's already sitting inside your own repository, you come back to Amplify, click on GitHub and click on Next. So it will ask you to sign in. So you need to like authenticate it so that Amplify can have access to GitHub. So now that you've done that, right, after you log in, so the next thing is to select your repository. So click on this. This is the repository that we're currently using, which is quick somewhere back. Then select the branch, which is main. Click on next. Scroll down. We don't have any build stage now, so click on next and save and deploy. So we're going to wait for this guy to deploy the application. And yeah, so this is how the quick sum website looks like, right? So let's quickly do a base and exponent. So you see what happens, right? Click on 5, put any number 3, and click on calculate. Now, when you click on calculate, see request field, check the console. And that's because we've not added our API, this guy, which is the that has the invoke URL. So once the invoke URL is inside the web app, it will pick these two, which is our event, base and exponent, take it to Lambda, run this calculation, bring the results here, and also save it inside our database. So remember, we've copied our API URL on our notepad. So to add this to it, right, we go back to our source code. So you don't need to pull down your deployment anymore because we already have GitHub, and this will give you continuous integration. Anytime there's an update here, it reflects directly on your web app. That's why we're currently using GitHub for continuous integration. So click on the index.html code, click on the edit button, which is this pen icon, then scroll down to line, I think 400 and something. Yeah, 434. So where you have this, add your API link. So I'm going to copy my URL and I'll be pasting it inside there. So copy the URL, replace it with what we have here. Paste this and click on commit changes. Commit changes. So let's see what happens inside Amplify. So you can see immediately Amplify receives the update, right? And it's going to try to deploy this app over again. So let's wait for it to be done. And we go into the website now and try to do the deployment over and over again. So it's currently deploying it now with the API. They were going to try the calculation directly from the front end. So now it's done deploying. So click on the URL. Scroll down. So let's enter a new number for calculate. And voila, we have a result. So now our API is currently working. So let's go and check if it stored the result inside our DynamoDB. So let's refresh. And yay, we have this stored in our DynamoDB. So we built it end to end and we have our application live inside AWS. So the last step is to clean up all our resources. Remember, if you are not running anything, ensure you clean up all your resources after you're done practicing. So let this be like a culture. Every time you're done practicing, always make sure you clean up all the resources. So let's start from our Lambda function. So we'll be closing each tab as we're currently doing this. So go to your functions, confirm. So Lambda has been deleted. Head up to your API gateway as well too. Go to APIs, delete this. So you can always copy this and paste it here. Confirm, delete. Done with API. For your Amplify application as well, so go to app settings Go to general settings, click on delete app, then type in delete the app. So you can close this up. Your DynamoDB as well too. So go to your DynamoDB dashboard or go to tables. Go to tables, click on the checkbox and click on delete. So then confirm. So it's currently deleting. So by the time it's done, you're going to see deleted in this state. Okay, so now it's done deleting. So you can see this is down because we've pulled down all our infrastructure. So if you have any question, please use the comment section and I'll be happy to attend to you. See you guys in my next series.